Let's start here. This is Earth, a pale blue sphere suspended in the dark velvet of space. Every person you've loved and every civilization that has ever risen exists on this single world. But even our grandest landmarks are tiny in context. Take Mount Everest, our planet's highest point. If you shrank Earth to the size of an apple, that mountain and our oceans would be a thin layer no thicker than its skin. The physical distance is equally humbling. Our planet is roughly 8,000 miles wide. If you flew a commercial jet straight through the center of the Earth at cruising speed, you'd be in the air for over 13 hours. We view this globe as a massive, near-infinite world. Yet, compared to the cosmos, everything we have ever experienced occupies less space than a single grain of sand on a beach. To see the scale clearly, look at the sun. It is a fusion reactor so vast you could pour 1,300,000 Earths inside of it before it was full. This illustrates the immense distance across our planetary neighborhood. Sunlight travels at 186,000 miles per second, yet the void is so wide it takes over 4 hours for that light to reach Neptune. And that is just our immediate driveway. To reach Proxima Centauri, the absolute nearest star beyond our sun, you have to travel 4.2 light-years. A light-year is the distance light travels in 1 Earth year, roughly 6 trillion miles. If you shrunk Earth to the size of a marble, the sun would be a beach ball sitting 3 full football fields away. Our immediate neighborhood is composed almost entirely of empty void. Zooming out brings us to the Milky Way. We occupy a tiny position in one of its spiral arms, sharing this space with at least 100 billion suns. From edge to edge, our galaxy spans 100,000 light-years. If you were driving a car at highway speeds, it would take you 2 billion years of continuous travel just to cross it once. Our solar system orbits the galactic center at a glacial pace. We complete one lap roughly every 250 million years. In the entire history of planet Earth, we have only finished that journey 18 times. All of human history exists as a microscopic speck, drifting in one tiny offshoot of this massive rotating island. But we are not alone. In the 90s, the Hubble Space Telescope was pointed at a specific tiny patch of sky no larger than a grain of sand held at arm's length. The results corrected our assumptions about empty space. That dark pinprick was overflowing with 10,000 entire galaxies, each containing hundreds of billions of stars. When you apply that immense density to the entirety of the night sky, the totals reach 2 trillion individual galaxies, not stars, galaxies. These trillions of galaxies are organized into the cosmic web. They cluster along filaments of dark matter, an invisible substance that provides the gravitational scaffolding for the universe. Scientists have noted that this large-scale structure bears a striking resemblance to the neural networks inside a human brain. The filaments and nodes where galaxies intersect look remarkably like synaptic nodes, the junctions where neurons communicate. It is a structural parallel that shows complexity follows the same organizational patterns at every scale. This creates a massive discrepancy between time and distance. The universe is approximately 13.8 billion years old, yet because space has been expanding while light travels, the earliest objects are now 46.5 billion light-years away. This map displays the limit of our reality, a sphere 93 billion light-years across. This is the observable universe. We cannot see beyond this boundary because light has not had enough time since the start of the cosmos to reach us. This is our cosmic horizon. Because the expansion of space is accelerating, distant regions are racing away from us faster than light. The light they emit right now will never reach Earth. However, physics suggests our visible bubble is just a fraction of the whole. Some models of inflationary cosmology, the theory of the universe's rapid early growth, suggest the total universe is 10 to the power of 23 times larger than what we can see. If those models are correct, everything we can ever observe or measure is a subatomic speck within an incomprehensibly larger, potentially infinite reality. Now, pull the focus back, away from the infinite, past the trillion galaxies, past the Milky Way, and back down to you. You are physically connected to this vastness. The iron in your blood was forged in the cores of dying stars billions of years ago. We are ancient cosmic debris, evolved to look up and comprehend our own scale. In a universe this vast and structured, is it possible that a self-aware child of the cosmos is truly alone?